Hi, Chem Team. When we say something is unstable, we just mean that it's very easily or quickly changed. And when we say something that is stable, we mean that it's sturdy or that it's hard to change. Atoms can be stable or unstable too. Stable atoms tend to be stable because they have full valence or outside shells of electrons. So examples of stable atoms would be things like neon, which if you look at its outside shell of electrons, has a completely filled valence shell. Or helium, which has just a single outside shell of electrons, which is completely filled. Whereas an unstable atom would be something like lithium, which has an inner shell which is filled with electrons, but its valence shell, its outside shell, is not completely filled. Now what's interesting is that atoms tend to stabilize over time. Take for instance sodium, which has 11 protons and 12 neutrons, whose 11 protons attract 11 negative electrons. Now what you'll notice is that the electron in the third shell is in a very unstable position. Because it's so far from the nucleus, it's only very loosely attracted to sodium's protons. And so if we come over to this half of the screen, what will happen to this electron is that sodium will lose it. And in the process, after that electron leaves, sodium will now have a completely filled valence shell. Now what's interesting is that in the process of losing a negative electron, sodium will gain a positive charge because while it used to have equal numbers of protons and electrons, there's now one more proton than there are electrons. There's 11 protons now, and there are only 10 electrons. So we call sodium, after it has been stabilized, we call it an ion, which is just an atom with either a positive or a negative charge. Whereas sodium, before it was stabilized, was neutral. Ions can have negative charges as well. Take, for instance, a neutral fluorine atom. Fluorine has 9 protons that attract 9 electrons. But you'll notice that fluorine's valence shell of electrons isn't stable. It would be more stable if it had this last orbital in its second shell filled with electrons. And so if we come over here to this after image, you'll notice that fluorine tends to gain an electron to fill up its valence shell. And in the process, fluorine will become a negative charged ion. It'll get a charge of -1. I know that's kind of hard to see on your screen here. It'll get a charge of -1 because there's one more negative electron now than there are positive protons. There are now 10 electrons and only 9 protons. So we can represent this fluorine as fluorine with a -1 charge, whereas before it was ionized, fluorine had no charge at all. And that's it. At this point, you guys have a couple of practice questions. We'll see you in class tomorrow.